Hello and welcome to the ninth video on our series on labor market search. In this video, we're going to find the equilibrium of the Diamond-Mortensen and Pissarides model. So as we were saying in the previous video, the key to finding this equilibrium is to solve for the labor market tightness. Everything actually depends on the labor market tightness. And we're going to get it from the decision of firms to post vacancies. So recall that the value of posting a vacancy is going to be equal to the negative of k, that's going to be the cost of posting the vacancy in the first place, and then the expected value of getting the vacancy filled given by PF times Z minus W. Z minus W being the profits that the firm will get if it gets to hire, PF being the probability that the firm actually hires. And we had seen that firms are going to just keep posting vacancies forever if V is greater than 0. So in equilibrium, V better be equal to 0, because or else firms will never stop posting vacancies. If V is less than 0, of course, firms will just stop posting altogether. And so we can see that in fact V has to be equal in equilibrium thanks to the market tightness. And we briefly touched on these in our video on firms, but here it is again. If the value of posting vacancies is positive, then more vacancies are going to be posted by firms. As firms post more vacancies, they increase the tightness. Remember, J is equal to A over Q, A being the total number of vacancies. So more vacancies posted is going to increase J. But as we saw in the previous video, a higher tightness makes it harder for firms to be able to fill a given vacancy. So PF, the probability that the vacancy is filled, is going to go down. And if PF goes down, that's going to reduce the value of a vacancy. Now, this is going to keep happening. More vacancies are going to be posted, tightness is going to increase, that's going to reduce the likelihood that you can fill a vacancy, that's going to further reduce V, and it's going to keep happening all the way until V is equal to 0. And there is no longer an incentive for firms to post more vacancies. So in equilibrium, it has to be the case that if V is equal to 0, that PF being the probability of finding a vacancy, is exactly equal to K over Z minus W. You can further replace by the equilibrium value of W. Remember, because we're having this wage bargaining, we're splitting the total surplus Z minus B, and then firms are going to get a fraction 1 minus A of Z minus B. Then you're going to see that that's equal to PF, which is equal to the term given by the efficiency times M 1 over J. This is why this side here is going to be decreasing in J. This is a function that's decreasing in J. The left-hand side is going to be a constant. That's neat because it's going to let us graphically define the solution. In this graph, what we have is different values of tightness that are going to give me different values of PF. This blue line is PF, which remember, it's equal to E times M of 1 over J. So this blue line is PF. And what we want in equilibrium is that for a given value of K over Z minus W, for that value, we can find the equilibrium J, the equilibrium tightness. Of course, we're going to know that we can change this value of K, change the value of Z, change the value of W. That's going to change the tightness we're going to get. Actually, in a very intuitive way. So for instance, if K goes up, that means if vacancies are now more costly to post, well, of course, firms are not going to want to post as many vacancies. That's going to mean that tightness is going to be reduced. But if K goes down, the opposite is going to happen, and more vacancies are going to be posted. That's going to increase tightness. Same thing happens, for example, if Z goes up. If Z goes up, then the profits that the firm can get are going to be higher. And as those profits are higher, then I have more incentives to post vacancies and try to hire more. And so that's going to reduce this value, which is going to mean that in equilibrium, there is going to be a higher vacancy, vacancy rate, a higher tightness. Okay, now that we know the tightness, how do we find Q? Well, remember, if we know the tightness, we know PC, we know the probability that you find a job. And so we can go back and recall that we want to participate up to the point that this function P of Q that measures the total number of agents that have a theta I less than this value, We want that this function P of Q is equal to the expected value of participating. The expected value being the probability that you don't find a job times B, the probability you find a job times W. Now, what's going to happen here is the following. You can replace W by the equilibrium bargain wage. And that's going to tell you the following. This same value, it's equal to B that you get for sure. And then with probability PC, you get an additional boost. You get a fraction of that surplus, a fraction A of the surplus of the match. This is a very nice way to write things because it lets us see that PC actually comes in only in one place. And so now, given the value of J, we know exactly the value of workers for joining the market. Because we know B, we know Z, we know A, all those are taken as given. And the only thing we didn't know was PC. So what we're going to do now is realize that PC can be expressed in terms of the tightness. And so we need to define this in a way that we can find the Q that guarantees this equality, where J is taken from the previous problem of the firm. How does this look graphically? Well, we actually start from the bottom up. This bottom graph, that's a bit blurry, I apologize, but you're going to be able to see it well when you download the slides. It's the same graph we had 2 slides ago. This is market tightness. This is the probability of filling a vacancy. Here we have the K over Z minus W. That K over Z minus W is going to get you the equilibrium tightness. And then you can project the equilibrium tightness to this function, the supply function that we had from before, to get the Q. In order to make this graph, we swap the two axes of this with respect to the one that we saw in the video on the consumer. So with respect to that video, we just swap the axes. Before we had Q on the horizontal axis, and now we're going to have it on the vertical axis so that we can go directly from labor market tightness into Q. The key here is that labor market tightness, let me go back one slide, is the only variable here defining the expected value of joining the labor force. So by knowing what J is, you know the value of joining the labor force. You only need to find Q through the inverse image of this function P. That's what we're doing here. Again, first, we're going to find the value of the firm. That's going to tell us the J in equilibrium. That J in equilibrium we can project to the problem of the consumer to find the equilibrium Q. Once we have that, we can then define all the remaining variables of the model in terms of functions that we already know. For example, the unemployment rate. It's going to be equal to the number of employed people relative to the economically active population. Now, if we distribute here, Q over Q is 1, and M over Q, it's exactly given by PC. And so we actually, by knowing J, we know directly what's going to happen to the unemployment rate. So even if you don't know exactly what's going to happen to Q, if you know J, you already know what's going to happen to the unemployment rate. There is something similar to the vacancy rate, where you know J, then you're also going to know what the vacancy rate is going to be. Then finally, output in this model is going to be given by Z times the total number of workers. Now, how do we know how many workers there are? One simple way to know it is the following. If Q workers were trying to find a job and PC of them find it, then M better be equal to PC times Q. This is neat because it lets us separate the total effect on output into 3 components. There is a productivity component in Z. There is a labor friction component. This is going to be the probability that people find a job. That's going to be determined by the labor efficiency E and by the matching efficiency E and by the market tightness. And then there is going to be a level component where a higher Q, more people participating, it's going to end up meaning a higher output. So in some of the applications, you're going to find that you know what happened to J, but you perhaps don't know what happened to Q. So if Q is ambiguous, we might not be able to determine what's going to happen to output, but we will know what happens to the unemployment rate. And through these diagrams, we also know what's going to happen to other variables in the economy. With that, we found all the variables, and so we finished finding the equilibrium of the model. In the next video, we're going to talk about some comparative static exercises.